diffusion of detergent. Okay, what we have here a glass of detergent powder and a beaker of warm water about 200 ml. Okay, for this experiment, we just add the detergent powder into the warm water. Okay, see? Okay, now, let the solution rest for the 10 minutes. Okay, this is after 10 minutes result. Now, let we observe the water. Okay, as we can see, the viscosity of the water is more higher compared to before this, and we can see the color of the water is turned to cloudy from the colorless. This is because the reaction of mass diffusion has been take place.
Diffusion is the thermal motion of all liquid or gas particles at temperature above absolute zero. The rate of this movement is a function of temperature, viscosity of the fluid, and the size of particles. Diffusion explains the net flux of the molecules from a region of higher concentration to one of lower concentration. Once the concentrations are equal, the molecules continue to move, but since there is no concentration gradient, the process of molecular diffusion has ceased and is instead governed by the process of self-diffusion. Originating from the random motion of the molecules, the result of diffusion is gradual mixing of materials such that the equilibrium has been established. The end result of molecular diffusion is called as dynamic equilibrium. In a phase with uniform temperature, absent external net force acting on the particles, the diffusion process will eventually result in complete mixing.
When the mixture is initially added into the water, there is an imbalance of a commodity in the mixture. Then, the mixture tends to redistribute until it reaches equilibrium. This tendency is often referred to as the driving force, which is the mechanism behind many naturally occurring transport phenomena. After 10 minutes, the commodity simply creeps away during redistribution, and thus the flow is a diffusion process. The rate of flow of the commodity is proportional to the concentration gradient, which is the change in concentration per unit length in the flow direction, and the area normal to flow direction. So guys, this is basically the diffusion from a microscopic and macroscopic point of view. Initially, there are solid molecules on the left side of a barrier, the purple line, and none on the right. The barrier is removed and the solid diffused to fill the whole container. At the top, a single molecule moves around randomly, while at the middle, with more molecules, there is a clear trend where the solid fills the container more and more uniformly. At the bottom, with an enormous number of solid molecules, all randomness is gone. The solid appears to move smoothly and systematically from high concentration areas to low concentration areas, following the Fick's law.
Hi, so we continue to our second experiment, which is the extraction of iron from cereal. So as you can see, these are the materials that we use. First of all, this is a magnetic stirrer, cereal, some water, and lastly is a blender. Okay, let's continue to demonstrate the experiment. So firstly, we take a blender container and put the cereal into the blender, some water,
there are iron attached to the magnet. Okay, for the experiment, did you believe that the iron in the cereal? So it proved that from the experiment, there's iron contained in the cereal.
So you can also check at the cereal box how much does iron contains in each serving. Hi, my name is Narita Ahmad, and I would like to explain about the theory of the extraction of iron from cereal. So as we know, it is the same as the theory of extracting iron from iron ore using blast furnace. So firstly, the occurrence of iron. Iron is very reactive, and it is found in nature in the form of oxide, carbonate, and sulfates. So the main ores that we found are hematite, magnetite, and pyrites. Second is the extraction of iron. So we have 3 steps for the extraction of iron. Firstly is about the concentration, where the ore is crushed and it is broken into small pieces, and it is also concentrated with gravity separation process. And the second step is the calcination, where the ore is then heated in the absence of air. Third step is smelting. The concentrated ore is mixed with calculated quantity of coke, limestone, and also the mixture is put in the blast furnace from the top. So blast furnace, as we know, it is very tall, cylindrical furnace made of steel, and it is also lined inside with fire bricks, and it is heated with the help of hot gases. So last one is the extracting iron from iron ore using blast furnace. So the common ores are both iron oxide, and it can be reduced to iron by heating them with carbon in form of coke. Coke is cheap and provides both the reducing agent for reaction. Air blown into the bottom of furnace is heated using hot gases from top, and coke burns in blast air to form carbon dioxide. Thank you.
So guys, that's all from us. And don't forget to like our video.
See ya.
And then again I say, I'm hoping we can make some wishes out of airplanes.
Can we pretend that airplanes in the night sky like shooting stars? I can really use a wish right now, wish right now, wish right now. Can we pretend that airplanes in the night sky like shooting stars? I can really use a wish right now, wish right now, wish right now.